Thank you. You can see my super awesome keyboard up there. Just kidding. Oops, how do I go to the next one? Oh. Okay, here we go. Just a quick note about me. That's my name and my Twitter handle. I'm a Django developer at Jonas and the Wolf in Berlin. This is my second PyCon UK. I love the focus on microcontrollers and education. The PyCon in Germany mostly focuses on PyData, and I've been looking forward to coming back since last year. So let's begin. Our history of the keyboard actually begins with the piano. You'll notice a few parallel here, namely that both the keyboard and the piano have keys. They're arranged on the board, and they're both input devices. In fact, a piano is actually referred to as a keyboard, bringing the comparison full circle. When I told people I was building keyboards, they thought I was actually building piano keyboards. Another thing they have in common is that they both output letters. You might say, I know a piano actually outputs sound, but when you press little C, you're actually outputting the letter C. So the motivation for these early typewriters is actually the telegraph operator. This is a one-key keyboard that they would use. For those of you too young to remember a telegraph, they were the original instant messages. So you wrote your 140 characters, sometimes less because they charged by the letters. You paid your sum, and the operator would tap the message in Morse code on the keyboard with this one key. It would then travel through the wires, and the operator on the other side would try to keep up and scribble down the message, and then hand it over to your friend at the other end. So it was sort of like the early form of Twitter. I sort of cheated, and this is actually from 1900 and not the 1850s. So, given that a telegraph operator could send Morse code at 70 words per minute, but only transcribe at 30, they needed a new system to write faster, or rather communicate faster. So in 1846, this man named Royal Earl House, which is his real name, introduced the printing telegraph machine. This one ended up in Russia, so the keyboard is also in Cyrillic. So when the operator pressed the key, it would automatically output Morse code to the wire without having actually to know any Morse code. The machine on the other end, and you'd need another one of these, wherever your destination was, would decode it and print the letter out for you. The problem was that these machines broke down quite regularly. They had a lot of moving parts. But they were the prototypes for the early typewriters. This is a close-up of the keyboard. You can see on the black keys at the top goes from A to N, and then in reverse order, slightly modified on the bottom. So here's the first typewriter to use a semicircular block to arrange the letters that would eventually hit the ink onto the paper. This one was patented by Samuel Ward Francis of Newport, Rhode Island in 1857. So because it printed a C in the middle of the paper when you would type in the C key, instead of playing a C note, it was known as a literary piano because it had letters and it had silent music. A few years later, in 1868, you have Christopher Lapham Sholes with his typing machine. So Sholes is important to know because he starts here and works the typewriter up to what it is in 1878. So you didn't need to build a full machine when you did a patent, so this is just sort of like a sample machine. His improvements in this machine included a ribbon to hold the ink and a better way to hold the paper, which is why he was granted a patent over something like this. So this is one of the early typewriter layouts. This is patent number 2077559 from 1878. If you look closely, you can see the M on the end of the middle row, and the keys are switched on the bottom, the Z, C, X, V. I believe now Z, X, C, V. And what he did is he put the letters in the grid, and then put the row numbers on top. You'll notice it's not in a perfect grid, but rather staggered. The reason being is that when you would press on one of the keys, it would move a lever, and it would hit it would cause the hammer to move and strike the paper on top. The only way to get this arrangement and have it work on a mechanical basis was to stagger the keys. The thing, though, is that the typewriter itself wasn't popular until Remington started mass-producing their first typewriter, the Scholes and Gillen typewriter in 1874, with the same layout that was in the patent, which is a layout very similar to QWERTY. Here's another close-up, the Z and the C are swapped, and the M is on the other side. Eventually, in 1848, Oh, okay. So the common myth is that Scholz rearranged the letters to make them harder to jam when the typist was typing really fast. But the truth is, according to Koichi Yasuoka and Motoko Yasuoka in their paper on the prehistory of QWERTY, he actually put in a lot of work to optimize the arrangement of the keys to make it faster to type on. So there's certain pairs that he put together to make it actually faster. At this point, everyone was typing with 2 or 3 fingers. When he did this design, this is the Remington number 2 in 1848, you get the final QWERTY layout, which has essentially remained unchanged for 148 years. You'll notice the M is migrated down and the Z and the X are swapped. Presumably this was done to avoid patent infringement, so that you get another patent and actually make money off this typewriter. Right after this typewriter came out, William Ozum Wyckoff of Ithaca, New York began to teach a 6-finger typing method, and then touch typing really took off. In 1882, a couple years later, Elizabeth Margaret Longley presented her 8-finger system, which is essentially a 10-finger system because you have the thumb on the wooden spacebar on the bottom, at the first annual International Congress of Shorthand Writers in Cincinnati, Ohio. So this is when typing really took off, and from this point, no one that used a typewriter resorted to hunt and peck. If you owned one of these machines, and these machines cost a lot, you would essentially touch type. So the question today is, can you touch type? So the first tip to optimize input is basically to learn to touch type. I know that many of us are programmers, and many of us already know how to touch type. But when I learned, I had a really difficult time in high school. It was one of the requirements to take a typing course, and I didn't know if the instructor wanted speed or accuracy. She wanted both, I had neither, I barely passed the class. But I discovered, as I got better, that when you type, you no longer rely on thinking about the letters and A goes here, Q goes here, and you actually rely on muscle memory to help you type the words out. So instead of thinking about the letters and the placement on the keyboards, you actually start to think about the words and how they pass through your brain. So the words go through your fingers at literally the speed of thought, or for most of us at 80 words per minute. So back to the history lesson. In 1926, Dr. E.A. Kloppenberg, in his book, Rationalisierung der Schreibmaschine und ihrer Bedingung, which translates to Rationalization of the Typewriter's Operation, did a lot of studies on how typewriters were being used in the office. He discovered that to relieve shoulder pain, the best thing to do was to split the typewriter to be shoulder width. Tip number 2, split the keyboard. 100 years ago, when he wanted to split the keyboard, this was technically unfeasible. You'd have to develop a niche product that not many people would buy, and the letters would have to be in the middle. It would have been technically challenging since the force that you pressed the keys was the force at which the hammer struck the paper. So you'd have someone who'd be literally smashing down the keyboard. But now in the age of plastic, silicon, and wires, it's actually dead easy to create a split keyboard. You can even buy a few off the shelf if you don't feel like building one yourself. So from cheapest to most expensive, on the upper left, you have the Microsoft Sculpt keyboard at 75 pounds. The Kinesis freestyle keyboard, which is an actual true split keyboard at 120 pounds. The Gold Touch V2, which sort of splits side to side for 150 pounds. The Ergodox EZ at the bottom at 220 pounds. And if you really feel like splurging and want just one unit, you can use the Malcolm keyboard at 450 pounds at the bottom. The next big event in keyboard history, and I know many of you have heard of this, is the invention of Dvorak. This is 1936 when August Dvorak scientifically studied the existing QWERTY layout, and he optimized for finger travel and speed. He completely scrapped it and put in a new layout. So, I know we're going really fast, but this is tip number 3, using an alternate layout. So Dvorak took the most common letters in the English language and put them on the home row, right there, the vowels on the left-hand side. So when you start the keys, most of them would already be where your hands already were, and this would lessen finger travel time. So the following stats from this section are taken from the Carpalx website, which is right here at the bottom, if you want to go to it. The website has a lot of resources, a lot of statistics on QWERTY and other keyboard layouts, including a super optimized layout, which of course, 5 people in the world probably use. So on QWERTY, you have 34% of the keys that you type are on the home row. The vowels are mostly on the top, the E, the I, the O, and the U. And the very common T are on the top row, so 51% of the time you're actually reaching up to type on the top row. On Dvorak, however, you actually have 71% of the keys that you press on the home row, so there's less action on your fingers. There's also hand alternation. On Dvorak, your hands alternate 62%, and that basically means that you can type faster if you hit one key on the left, one key on the right, instead of typing two consecutive keys with one hand. So switching to QWERTY has 51% hand alternation, which means 51% of the time you're using the same hand. So Dvorak reduces your overall typing effort to 70% compared to that of QWERTY. So I tried Dvorak about a decade ago and I couldn't get into it. The X and the Z, let's go back to that just for a second. The X, the C, the V, the Q, and the W are all weird cases, like when closing windows, like couldn't copy or paste. So it was really frustrating. So what I did is I looked for another layout and I switched to Comac. So Comac reduces the typing effort overall by 39%. This is Comac, by the way, again. Oh no, this is Dvorak. I'm sorry, I have the wrong slide. What Comac did is that it kept the Q and the W in the same places on the bottom, the X, the C, and the V also on the bottom left. And you also have a rearrangement of the letters in the home row. So Shaipoman, the inventor of Comac, only switched 19 keys, so it was actually easier to use with, essentially, it was a Dvorak for the computer age. So I really like Comac. I like that I'm not moving my hands all over the place, and it's about having comfort in typing and not in speed, so I'm not moving my hands everywhere. The good news is that for Comac and Dvorak, the two keyboard layouts are actually pre-installed, so you can actually switch right now. If you use a Windows machine, you have to download it and install it. The bad thing, however, is that you have to invest a few weeks to retrain yourself in learning how to type. But after this period is done, you'll type as well, or even better, as you type afterwards. So there are a lot of popular typing tutors. When I switched to Comac, there was one that I used called Master Key on the Mac. So you'll have to find one to work for you. I know that Comac has become pretty popular, so if you don't know how to touch type, then I recommend you just switch immediately to one of these layouts, and you don't have to retrain yourself. So with the introduction of the electric typewriter, the keyboard itself was decoupled from the hammers that printed the keys. The typewriter now used not microprocessors, but electric components. So when you struck the key, it would send an electric signal to hit the hammers. It's important to pause and reflect on what a missed opportunity this was to reinvent the keyboard. You didn't need the stagger anymore because you'd press the key would send an electrical signal to the switch. But the thing was that when they were trying to get this out, people were going with what they were familiar with. So you'll notice that this still uses QWERTY instead of anything else. There's a big debate on path dependence, which is a term that economists use. But we have QWERTY because it was just the most comfortable and the most popular, or if it is in fact the best layout. With Comac and Dvorak on board, you know it's not the best layout. So computers started becoming more common, and they needed a better form of input, especially once programming became text-based. The first computer keyboards were actually typewriters that were hooked up to mainframes, or something like this, which is an electric typewriter that would print directly to magnetic tape, which would then be used in a UNIVAC computer. This is the K keyboard from Cromer, who was an ergonomics professor and researcher. In the 1970s, he developed experiments and discovered that people actually liked typing on ergonomic keyboards. They liked the tilting. And the other interesting thing about this keyboard is that it has what is known as an ergolinear layout. So instead of having the stagger be from side to side, as you have here, the keys follow the normal curvature of the hands. So when you type, you're moving your hands up and down, and you're not moving them from side to side as you were for a normal keyboard. So this keyboard is called the K keyboard, not after himself, but Klockenberg, with the German book in the beginning. Okay, so now we come to 1984. In 1984, the infamous IBM Model B was introduced. Model M was introduced. This keyboard was built like a tank, and it was also as loud as a tank. The thing was that it used buckling springs. So you'd have a spring, and then you would hit the key to the bottom, it would make contact, causing this great big noise. So at the time, there was a lot of, if you watch old movies or Halt and Catch Fire, you'll notice the noise in the background of everyone going click, 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 click. But this essentially set the benchmark for what a great input device could be. A lot of these are still in use today, and if you find one of these, you can actually sell it on eBay for about £100 or restore it yourself and reuse it. There's even USB adapters that you can plug into and just plug into your computer and go.
You can buy them.
You can buy them, yeah.
With additional keys.
Yes, yes. So in 1984, another thing also happened. The Cherry Corporation, the German-American company that had already been producing switches for cars, switches for light switches and everything, received a patent for the MX switch. And this switch is important because this switch is actually the one that you'll use if you build a keyboard. If you get a good mechanical keyboard and take the keys out, this is essentially what you'll see underneath. So these are still used today. The patent, however, expired, and once the patent expired, you had a lot of other companies producing crazy clicky switches, linear switches, red switches, blue and yellow switches. But this is essentially what sets the standard for mechanical keyboards today. So the Model M and the keyboards made with cherry switches both work the same way, the way that all keyboards work. So this is the matrix. The matrix is a configuration of a grid on the printed circuit board. It's made up of wires, and essentially when you hit a key, it closes the switch and sends a signal to the keyboard. So tip number 4 is to buy or build a custom keyboard. Since 1984, there have been a couple significant events that happened that have really helped DIY projects take off. The first was the rise of DIY maker culture. 3D printers have become more common, especially in the home. You also have laser cutters, so essentially you can 3D print any keyboard layout that you want, even one conforming to the curvature of the hand, as you saw earlier in Klockenberg's keyboard. The second thing was the rise of the microcontrollers. So the most commonly used ones are the Arduino Pro Micro and its cheap clones, such as the TeamZ 2.0. Last year, the keyboard community came out with a couple of microcontrollers that used USB-C. The reason was that the Pro Micros had the bad habit of snapping off the USB port, so then you'd have to resolder your keyboard. You'd have to resolder the microcontroller on your keyboard. So, just really quickly, some of the examples that use microcontrollers are the Aerodox. You can buy it fully assembled for $250 or get a kit. This is the keyboard by my friend Mark that made me rediscover keyboards and actually start building my own keyboards. You can buy one fully assembled for $180 or again in a kit. The one I built a year ago was this one, which is a split version of the Prionic, which you just saw. I actually keep my mouse in the middle, but this is the first keyboard that really got me into keyboards and got me to learn a lot about keyboards themselves. My favorite layout is also based on the Ergodox and the Klockenberg, and this is called the Iris. You can't actually buy a kit, but you can put this together yourself with a little bit of soldering knowledge. So the thing is that you have far fewer keys here than you do on, for example, an IBM Model M. Then you might ask, how am I going to get my enter key? How am I going to do delete? How am I going to do, page up, page down? And the trick here is layers. So when you have your phone, you press the 1, 2, 3 key, you switch from the QWERTY layout or whatever layout you use into the numbers. The third significant event that happened was code sharing on GitHub. So despite my advanced age, I only started programming 7 years ago. So I've never known the world without GitHub. But GitHub allowed better collaboration on projects, and you had everything centralized. So GitHub was one of the reasons, one of the things that allowed this project to come into being. So QMK is a project which is essentially a keyboard firmware software written in C that allows you to configure your own keyboard. On my keyboard at work, I actually, for my left thumb key, Down here, it's actually enter, but when I hold it down, it's control. You can also make the space bar, which on my keyboard is on the right side. If you double tap it, then it'll do delete. You can even determine how many milliseconds until this happens. The thing about doing this, about programming this layout, is that you have to make sure that you have no trailing commas, that all the braces are closed. It's a little bit tricky, it's a little bit of fiddling, but in the end, it's pretty okay. The hardest part, though, is flashing the microprocessor, because my microcontroller. It's just a lot of commands on the command line. But the QMK documentation, there's actually a lot of newbie guides. So the keyboard that I'm going to present is this one. When I was doing research for my talk, I discovered that, and I really wanted to build a Pi-board-based keyboard. I discovered that someone had actually written the software for it, so I didn't have to do it myself. So this keyboard, which I started myself, you have all the wires and everything. It uses a breakaway PCB, so all you need to do is do the diodes, the switches, and then bridge the connectors. There was a person, Max Cameron, on GitHub that already programmed it, so all I needed to do was essentially reprogram it, spend a couple of hours, and then a couple of hours more fixing problems with the physical keyboard and the diodes that I tried to do. I actually have I could do a demo, and I know that all demos go badly, but let's hope it works. So, no. Okay, so you can see that it actually works and that it actually types. Oops. Okay, there are a few other libraries that use Python. There's KWERTY render, which did the open slide where you saw the keyboard. PyKeyb, which you can design your own keyboard and output it in AutoCAD, and there's KMK firmware, which is a rewrite in Python of QMK. If you know, you have any interest, KMK is an active project and it is accepting contributions. Two resources that I found great were on Reddit, OLKU for ortholinear keyboards and mechanical keyboards. There's a couple of vendors that I used that were really helpful when I was getting the parts. This is the #1 question that people always have. And if you do end up building your own keyboard, you can actually reach me on Twitter at Mr. Rios. It's just like the Telegraph, don't have any fear. Just type me a message and hit send. Thank you.
We have time for one question.
Oh.
Yes. I just hope it works for the recording, but.
Do you have any idea how many people actually use overlook layouts? What percentage of people?
I don't know. I honestly don't know. I know that in the programming community I've come across a lot of people that use Formac and a few that use Dvorak. There's even a Dvorak area called Programmers Dvorak, in which I believe the numbers of the hub are also optimized for the frequency of use, which is pretty crazy. I don't know, but once you meet people, you'll find out. There's also mechanical keyboard meetups in many cities, and in those places you'll definitely find tons of people that use all the layouts.
I use Dvorak programmer.
Oh, cool. One person uses Dvorak programmer. Okay, two.
Great.
And Kinesis keyboard as well.
Oh, wow, cool. I use a keyboard sometimes with I work at home.
Fantastic. Many thanks, Daniel, and I'm sure he's going to be around and we'll be happy to talk to all mechanical keyboards enthusiasts or soon-to-be enthusiasts. Thank you very much, Daniel.